Welcome to our mini tutorial on linear regression. This tutorial will actually assist you in completing question number 3 of part 3 of the course project. For this tutorial, we are going to actually be using our data set that we're using for the entire project, which is the sleep data set. And if you look at part 3, question number 3, you are to conduct a linear regression on 3 of the variables. And what we're going to do is actually use at least 1 or 2 independent variables to predict a dependent variable. So for this tutorial, I'm actually going to use height and weight to see if we can use that to predict age. So if we go off to our data set and we want to conduct a linear regression, we go to Analyze, Regression, and then Linear. Again, our dependent variable is the variable that we want to predict, which is going to be age. And we're actually going to do 2 blocks. The first block is just weight. So we're going to see if we can use weight to predict age. Then we're going to add height. So we're going to have weight, and now we add height. So that's our second block. Now if we go up to statistics, we're actually going to click the majority of these options. And again, we're going to look at some 95% confidence intervals. And for our case-wise diagnostics, we're actually going to set our outliers at 2 standard deviations. And when we produce the SPS output, I'll explain why we've chosen all of these options. In your textbook, it does talk about different plots. For this particular tutorial, we are going to skip through those. So in SPSS, it then produces this output. All right. So it starts off with our descriptive statistics, which gives our mean and standard deviation for the 3 variables we're interested in, age, weight, and height. Our correlations should be identical to the correlations we got in the first and second part of this part of the project. So we can see age and weight are correlated at 0.154 and age and height at negative 0.013. Now these are not strong correlations, which we already knew, but I'm using these as a demonstration on what we're looking for to actually not happen when we run linear regression. All right. So as we continue down our SPSS output, it'll tell us that weight was entered in the Model 1, and then we added height in Model 2. So our model summary gives us a really good idea of, is this model going to be a good prediction of age? Again, remember Model 1 only included weight. Our R value was 0.154, which we saw from above, and our R squared is 0.024. This means that weight can be accounted for 2.4% of age, which is a very low R squared. And then when we add height to the mixture, so weight and height, we can see that R squared increased to 0.038, which means that height added an additional 1.4% of predicting age. Right. And so continuing down to the ANOVA output, this is really what's going to tell us, is this linear regression model a good fit? And in Model 1, again, which is only including weight as an independent, we have an F value of 5.28 and a significance level of 0.023. Now, we're looking for a very high F value because the F value basically means, the better a model is divided by how bad it is. So the higher the F value means the model is better. And so these are actually very low F statistics. And if you look at the example in the textbook, we had F statistics of 99 and 130. And so when we're seeing F values or F statistics that are this low, and significant values that are greater than 0.001, this is telling us this model is really not a good fit. Okay. So continuing down to our output, here we have our coefficients. And again, we're looking actually at model 2, which includes both weight and height. And if we look over here, we can see our constant of 59.720, and these are the coefficients of weight and height. So when we put together our linear regression equation, these are the values we're going to be using that will then help us predict age based on weight and height. Now, if you move over to the column that's labeled T, again, we have our T statistics. And once again, looking at model 2, which includes weight and height, we can see that we have rather small T statistics. And again, our significant levels are greater than 0.001. And so once again, this is telling us that this model is not a really good fit. What I also want to point out is our confidence intervals, and especially the confidence interval for height. You can see that the lower bound is negative 0.367 and the upper bound is 0.019. Now, when confidence intervals contain 0, it suggests that the value of B might be 0. It's obviously positive or negative, but it also could be 0, which means height as an independent variable could have absolutely nothing to do with predicting age. All right, so that's also found on page 308 in your textbook. So we always want to be cautious when we see confidence intervals that contain the value of 0. Moving down, we're also going to look at our case-wise diagnostics. Now, if you remember when we set this up, we chose 2 standard deviations for our outliers. And in this particular data set, we can see that there are 5 case numbers that actually are producing standard residuals that are plus or minus 2 standard deviations. And what that really means is that these predicted values, which are our age, those are what we're predicting, are falling above and beyond what they should be. And if you look at the ages of our data, it's our 3 oldest ages, 70, 84, and 71, and our 2 youngest ages of 18 and 19, that are producing these very high residuals. And again, remember, the residuals is the difference between the predicted value and the actual value in our data set. And we'll look at, when we test some values, where these residuals are coming from. So basically what this tells us is these 5 cases, or these 5 people in our data set are producing results with our linear regression equation that are just outside of what the equation can actually produce. So getting down to the residual statistics, we can again see that our predicted values are going from an age of 38 to an age of 58 with an average of 43. And then once again, you can see that the residuals are very high, meaning our model is predicting values that are negative 25 years below actual and 41 years above actual. So with very high residuals and very high standard residuals, meaning plus or minus 2 standard residuals above, that's again telling us that that height and weight are really not too good independent variables to help us predict age. So going back here, we can take a look at our regression model equation. So using those coefficients from the SPSS output, we have age equals our constant of 59.720 plus the coefficient for weight of 0.185 plus the coefficient of height, which is negative 1.74. Now, let me talk just 1 second about these coefficients. With a coefficient of weight being 0.185, what this tells us, as weight increases by 1 unit, age increases by 0.185 units if height is held constant. And if we look at the coefficient of negative 0.174 for height, this tells us as height increases by 1 unit, age decreases by 0.174 units if weight is held constant. Okay. And so now we'd like to test our model using some data from our actual data set, input height and weight into our regression model equation, and see how accurate our regression equation is predicting age. So using a height of 170 and a weight of 62, in our data set, case number 143 has this height and weight at an age of 70. So inputting 170 and 62 into our equation, the equation predicts age at 4161. Well, the age in our data set is 70. So again, we're off by 28, 29 years. However, if I test height at 168 and weight at 75, in our data set, case number 137 has this height and weight, and the age is 41. So I input those height and weight into my regression model equation, and it predicts an age of 44.363. Now that's only a couple years off of the actual age. And so when you're testing your model equation, which you will do, you do want to choose data that is approximately around the average age, but you also want to test upper and lower bounds. And as you can see, we did have 5 outliers in our SPS output, and let me bring that up again, showing you that those are case-wide diagnostics. These particular 5 cases were giving us residuals that were very, very high, which means predicted values that were above or below our actual data. So hopefully that will help you with part 3, question number 3. And in this particular question, you will be choosing 3 dependent variables, and then you'll also be choosing what independent variables you would like to help you predict that dependent variable. So answers are going to vary for this question. The examples in your textbook are wonderful. This is an example where obviously height and weight are not good predictors of age. Thank you.